Thank you, Ryan, for the introduction, and good afternoon, everyone. So I'm Manbir. I'm the soil fertility specialist. I'm also an assistant professor of soil fertility and nutrient management in SNR department. I joined Ohio State University in August, so about 6 months. Since I have arrived, I've been hearing a whole lot about phosphorus from different angles, whether it's crop production or water quality perspective. So I thought it would be worthwhile for today's talk to talk about phosphorus, uh, give you some insights into phosphorus based off Ohio field trials. And then moving forward, what are some of my plans when it comes down to phosphorus research? And also at the same time, get your feedback about, since I'm new here, trying to understand what kind of phosphorus related questions you have, or what are your perceptions with regards to phosphorus. So with that, so in today's presentation, we'll be talking about phosphorus, specifically about insights from Ohio field trials. I will start off with going over very broad overview of what kind of crop response we are observing in Ohio when we apply fertilizers. Simple, whether there is a crop response or not. And then I'll touch base a little bit about what's the significance of soil test phosphorus when it comes down to estimating the probability of crop response to applied P. Then I will dive down into how soils in Ohio are responding to applied P phosphorus. So I'll be touching base with respect to whether they are declining with specific phosphorus management, are they maintaining their P levels, or is there a buildup over the years with different fertilizer management techniques. And then I will conclude this talks with some of the research questions that I've been thinking about that would have quite a bit of P management implications, the way we manage phosphorus today in Ohio. So phosphorus, I'm pretty sure everyone over here at least is aware that phosphorus is an essential plant nutrient, whether you think about phosphorus being part of a plant as an energy currency in ATP or ADPs, seed maturation or photosynthesis, or any basic plant processes that you can think of, phosphorus is involved there. That's why it's an essential plant nutrient. So it's no brainer that plants need that nutrient. And if they are deficient in phosphorus, it's much more likelihood that we can get yield declines in there. Now, I wish the world was simple enough with regards to understanding, well, plants need phosphorus, apply phosphorus, get the yield response. But especially when we are talking about Ohio, things are not that simple. When there is a deficiency, we can get a yield decline. But if we are over applying phosphorus when it is not needed by the crops, then we end up into these kind of situation where excessive phosphorus is getting into the water bodies, causing toxic algal bloom. So that's not good either. So it's kind of a balancing act for us, at least at the moment, to fine tune our phosphorus management so we don't get yield declines with respect to crop production. But at the same time, we are not over applying that phosphorus, especially in the areas where it is not even needed, so that we can protect our environment, we can improve our water quality over the course of the time. So to get started, I just wanted to get a feel of how currently you are managing phosphorus at your farms or your clients' farms. So that's the QR code out there for scanning. If you are using mobile, you can just go into Google and type in paulev.com/Manbir Rakkar 489. It has two questions in there. The very first one is, when it comes down to phosphorus management, do you refer to the tri-state fertilizer recommendations? Simple yes or no question in there. And then second question is with regards to if you are applying phosphorus, if you are a grower, are you seeing some differences in there? Do you think that your applied phosphorus is giving you some economic returns? If you are a researcher or extension educators and you have trials ongoing on phosphorus, or if you have worked on phosphorus ever in your life in Ohio, have you seen phosphorus responses? There are a couple of options like never, half of the time, maybe more than half of the time, and then always. So I'll give you maybe another 30, 40 seconds to respond to that poll. Really, with that poll, I want to get a feel of how we are getting the information and how we are applying that phosphorus in Ohio State, at least. Again, in Google, you can just simply type in paulev.com/Manbir Rakkar 489, or you can just do the QR code. Don't need to put your name in there. Just skip that step and just answer the polls in there.
And Manbir, we have posted that in the chat as well, so they can click on the link from the chat.
Perfect. Thank you. All right. Let's move forward with regards to what we are observing when it comes down to phosphorus management and crop response, whether it's following tri-state recommendations, are we seeing phosphorus response or not? So at least when I think of phosphorus and try to put on a farmer's hat on my head, the way I think about phosphorus fertilizer application is to think about these questions. One, does pea fertilizer, at least in my field, is it always resulting in positive yield or not? Second, what is the likelihood of getting a yield penalty if I'm not applying phosphorus into the field? That's the second question. And then thirdly, if I am applying phosphorus, maybe there is a positive response, but how much is that? Am I looking at like 0.3 bushels per acre increase, or it's like 10 bushels per acre increase? Because at the end of the day, we have to think about our economics as well, phosphorus cost. Am I getting those returns in the end or not? So these are some of the questions, at least that pops in my mind when I think about phosphorus. And we had a study published recently by Coleman et al. That kind of touched upon all these three questions. So this study was, again, about testing crop response to pea fertilizer application, was conducted in Ohio. I'm not talking about 1 or 2 or 3 field trials. I'm talking about 457 field trials. That's a very robust data set. The trials were spread across 40 counties. Again, we are not talking about 1 or 2 years or 10 years of data. It's all the way down from 1979 to 2021, 45 years of data. Again, very robust data set that was collected for this specific study that gives us an insight and a kind of a confidence to talk about phosphorus management in Ohio. In this specific study, crops tested were corn, soybean, and wheat. If we look over the soil phosphorus status within all these sites, the soil P ranged from 2.7 all the way to 279 ppm. When we talk about the soil phosphorus level, if you refer to the tri-state fertilizer recommendation out there, for corn and soybean, that's 20 ppm. And then for wheat, the lower limit is 30 ppm. That means the soil P test that we had in this specific study, that was very wide range. There were a lot of sites that were likely to respond to phosphorus application. There were a lot of sites that were not likely to respond because inherently they had a lot of phosphorus in them anyway. So let's see how the crop responded. So going back to our very first question, does P fertilizer always result in a positive yield response? Here is the graph showing crop response to phosphorus at various soil P levels. Again, x-axis is soil P level. This is telling us about the yields. In this specific graph, the black dots, it's signifying yes. Yes means that there was a significant increase in yields with phosphorus application. And then the gray dots is showing no. That means with added P fertilizer, there was no yield increment. As you can see from the graph, there are a bunch of gray and one bunch of black dots. That means our very first question, does P always lead to increase in crop response? That is not right. Talking more specifically, out of 457 P trials, 107 trials actually showed a significant increase in yield with P application. If we go a little deeper into the data set, what is observed is that majority of the responsive sites, when they had phosphorus level around critical P level, that's 20 ppm around here, there was much more response in there. Once the P levels were more than that, the response level was less. The gray dots are much more prevalent in that region. That doesn't mean that there wasn't response of those sites, but if we are looking for like a trend, that was the main cutoff that we observed in this area. And another thing that you probably have noticed so far is that the response of crop also depended on what kind of crop we are talking about. To put things in perspective, on average, corn responded about 30% of the time, 30% of the trials had positive yield response. Soybean, only about 14%, and then wheat, about 37%. To summarize these results, crop does not always respond to P application. And what we are observing over here is that it really boils down to soil test phosphorus level. So that gives us an indication that how critical it is for us to analyze our soils to detect whether we're going to see a response or not. And then also at the end of the day, if you're getting a response or not, it kind of also depends on what kind of crop we are talking about. All right, our next question. If there is a yield increment with phosphorus, how much it will be? And second question, if I don't apply phosphorus, what would be the risk factor of yield loss? Again, based on this study, both of those questions, again, pointed us back to what kind of soil test P levels we are talking about. So again, when I will be talking about yield response and these two questions, I will be referring to this specific term relative yield. This is the yield that we agronomist people use to kind of standardize the yields across the board. So what basically it is, relative yield is what's the yield in the control, that means the yield with no phosphorus, divided by the maximum yield across all treatments. So in other words, if the value is 100%, that means control has the same yield with respect to the maximum yield that we observed in all the experiment, the value will be 100%. That means no yield increment. If there is a value less than 100%, that means our maximum yield was higher than control. That means there was a yield increment. Further down, the lower the value you are getting with respect to relative yield, the higher is the yield gain. Okay, let's get to the results. So this is the graph showing soil phosphorus level with respect to the relative yields. The data has been classified into 4 or 5 different classes based on different colored dots. The red dots are less than 10 ppm and all the way to the orange, which is more than 40 ppm. Now, if you glance very superficially, don't have to think very hard either. If you look over the pattern of the dots, when it is less than 10 ppm, the relative yield is ranging all the way from like near 42% to up into like 95% or so. However, when we go down this graph with respect to when the phosphorus levels are more than 40 ppm, all the dots are clustering around within this 90 to 100%. What it is meaning is that if we are adding phosphorus fertilizer, even if there is an increase in crop yield, it's not a lot because it's near to that 100% relative yield value. However, when it comes down to 10 to 20 or less than 10, there are a lot of instances that there is much more increment in yield that we are getting out of our phosphorus fertilizer application. Let me present this data in tabular form. It's kind of helpful for me, at least, to separate these things into different rows and columns and look into everything separately. So again, this table have soil P classification again, the ones we talked, ranging from 10 all the way to 40 ppm. This is number of trials that had that kind of P values in there. This column is about response rate. That means the percentage of trials that had positive response. And then this last one is, again, relative yield, how much an increment we got with phosphorus fertilizer. Let's break it down and take a look at it one by one. What is the likelihood of yield penalty if P fertilizer is not applied? So what it is showing is when it comes down to P classification, ranging from 20 to 30 or 30 to 40 or 40 ppm, that means our soils are much higher phosphorus levels. The response rate ranged from 12 to 14%. In other words, if you have a soil that has higher phosphorus levels, more than 20 ppm, the likelihood of response would be about 12 to 14%. That means if you don't apply phosphorus in those kind of scenarios, you won't get a yield penalty, most probably 86 to 88%. The story changes when the P drops below 20. In this specific trials, when the sites had phosphorus range between 10 to 20 ppm, the response rate jumped to 34%. Moment it went down to 10 ppm, the response rate even increased, almost double, 67%. So if you are in this range, one thing, much more likelihood of getting a pure response. In other words, there is much more risk of yield penalty if you do not apply phosphorus. All right, moving on to if I apply phosphorus, how much of a yield increase I'm expecting. Again, it boiled down to soil phosphorus levels. If our P levels were high, more than 20, 30, more than 40 ppm, the relative yield, the median one, ranged from 97 to 99%. So meaning if there was a yield increase, it was very minimal. The values are near to 100%. But the moment we go down to 10 to 20 ppm, median yields 92. Moving even further down with 10 ppm, it went down to 87. That means if you have low P soils, there is much more yield increment that you're going to get with P application with respect to one, if it's higher P, one thing, response rate's going to be low. Even if there is a response rate, the yield increment that you're getting won't be that much. All right, to summarize so far, phosphorus, no-brainer. It's an essential nutrient for the crops. In general, as per this study, crop responded to P application based on soil test P levels. Less than 10 ppm, trials, 67% trials responded. 10 to 20, 34%. And then more than 20 ppm, only about 12 to 14% of trials responded. With respect to yield increment, again, higher the soil test p-value, lower the probability of maximizing the yield with added P. So that's a summary from this huge data set that we are observing. So this was a very general discussion about whether crop respond to P fertilizer or not, and what's the significance of soil test P levels when we are trying to determine the probability of crop response or maximizing our yields and such and so. But what about more specific questions? If I'm applying phosphorus, how much I should be applying? And then second, if I'm not applying phosphorus, how would that affect my soil phosphorus levels and how would that affect my crop yields? I'm going to answer these two questions based on, again, long-term trials, 3 of them. These trials went all the way from 2006 to 2023. But I'll split these years into 3 parts to answer this question specifically. All right, starting with a little about what kind of experimental design these long-term trials had. So there were 3 sites, one in Wayne County, Wood County, and then Clark County. All these experiments are on farm at Worcester location, Northwestern, and Western. These trials were established in 2006. Crops tested in these 3 trials were corn and soybean. With respect to treatments, going back to the question of how much P I should be applying, one treatment was no P application. Second treatment was 1X, which was basically putting the fertilizer based on what the crop removal rate was. And then third treatment was 2X. That means we were putting double the amount of phosphorus that was taken off by the crops from the previous year. So we have kind of no application. This would mean kind of maintaining phosphorus level, replenishing phosphorus, what was taken out by the crop. And then the third one was kind of going towards the buildup of phosphorus, that we are over fertilizing our soils to kind of build up our phosphorus levels. Here is the data from these sites. Again, years, these are the sites, crops, no P application. This would mean 1X and then 2X. To summarize, across all these site years, which were 42 site years, there were 7 instances when P affected the yields. Out of those 7, these were the 5 where an increase in crop yield was observed with P application. And then also there were like 2 sites where we saw a decrease. Why? I don't know, honestly. But digging deeper into the data set over here, what happened to the soil response? Because when we think about crop response, the very first thing point we think about is what happens to the soil. Was the P levels were increasing or different, or how they were? So again, a little orientation about these graphs. Y-axis has soil P levels, x-axis has years. The red dots is no P application. Blue dots is 1X treatment, that was kind of maintenance zone. And then orange one that has the double amount of phosphorus application when it comes to crop removal rate. Superficial glance on these graphs, we are seeing some declining trends, no matter if it was 0, 1X, or 2X treatments. To summarize what happened when there was no phosphorus fertilizer, At least significantly, at two of the sites, phosphorus decreased by 2.5 to 1.6 ppm per year. When it came down to 1x treatment, phosphorus dropped down again significantly at two of the sites, Clark and Wayne, and that drop range was 1.5 to 1.9. When it came down to twice, where we were like over fertilizing, even in there, one of the sites, the Wayne County, saw a significant decrease of 1.1 ppm per year. Let's dig a bit deeper in there. So zero fertilizer treatment, where we saw a decline at Clark and Wayne County. Zero fertilizer means we were not applying fertilizer, but at the same time, every single year, crops were grown. So crops were taking that phosphorus. We were moving those phosphorus out of the system. It's not difficult to visualize that expectation. There was meant to be decline in soil phosphorus level. And in reality, that did happen. When it came to 1x treatment, again, we saw declines at two of the sites. What was 1x? We were supplying phosphorus based on crop removal rate. That means we were trying to at least maintain the level, if not build up or decline. Expectation that there won't be no buildup or no decline. Reality check, there were decline in phosphorus level, at least at two of the three sites. Third one, twice phosphorus level, we saw decline, significant decline at one of the sites. What was 2x about? Twice the crop removal rate. We were trying at least the build-up concept there. Expectation was that phosphorus level will increase with time. However, the reality check, at least at one of the site, there was a significant decline in phosphorus in these trials. To summarize, again, from 2006 to 2014 in these trials, again, infrequent response of crop to added P, just like the other trial we were talking about, 5 of 42 site years, there was a positive response. There was significant decline in soil TSP level, even with over-fertilization at one of the sites. Soil P levels are declining, crops are not responding. That kind of indicates that we are missing something in there. So it did kind of told us to go into a better understanding of soil P dynamics and how the crop response is really happening in all those sites. So that's kind of a piece of a puzzle at the moment based on this data set. Okay, let's move forward. I talked about 2006 all the way to 2014. In 2015, when all of the data was summarized, there was some change in the treatments. Zero, again, no changes. No fertilizer was applied. With 1x, we did increase the phosphorus level a little bit with respect to the crop removal rate. So if up until here, the plots were getting 80 pounds, now it was getting 100 pounds. And since we did not see any buildup with twice the crop removal rate, we bumped that rate to not twice, but 3 times of the crop removal rate to really see that buildup happening. And what happened during that period, so we are talking about 2014 to 2018, red months, 0 treatment, light blue is 1x, and then this dark blue is 2 to 3 times of the fertilizer rate. So just to summarize these graphs real quick, with respect to 0, there was still P decline, more or less. But something that stands out to me from this specific data set is when we talk about the critical soil test level of phosphorus, it's usually written as 20 to 40 ppm, 20 being the lower limit, 40 being the upper limit. 20 will be the critical soil test level. But if you are within this 20 to 40 range, you're good. kind of in the maintenance range. Above that, that's everything in excess. What I am observing, at least from these graphs, is starting from all the way from 2006, there are declines in soil P levels at these sites, but we are still in the critical soil test range. It hasn't really dropped below that range, at least at 2 of the sites. Western, we have gone pretty far down, but even after 12 years at 2 of the sites with no phosphorus application, we were able to maintain within that critical soil test level range. 1x maintenance, we were successful at this moment. We were kind of maintaining the phosphorus level in these 3 years. If you look, and then even with the build-up approach that we increased from twice to 3 times, we saw a buildup of phosphorus with that kind of application. All right, so 26 to 14 and then 15 to 2021, the moment when we were starting seeing what we would have expected to be seen, declines in phosphorus level with no fertilizer, maintenance with 1x, and then with over-fertilizing kind of built up. So when that was happening, then it was thought, okay, let's just stop all the phosphorus application across all the plots, whether it's 0, 1x, or 3x, and try to see what happens over the year. Will the crop would start to decline in maintenance or higher built-up ranges or even 0 ranges? And how would the soil phosphorus will decline over the years once we stopped, once we have like a maintenance range, once we have a built-up range, and then obviously a very sharp decline in phosphorus level in 0 treatment. So I have very preliminary data with that regard, but I was excited about this data, so I really wanted to share. So soil response to no P fertilizer. So again, we are talking about around 2021 when we stopped phosphorus application at Northwest, Western, and Worcester. And if you glance again very superficially, you can see that it is kind of declining. 0, soil P is declining. 1x, it declined sharply, and then it's kind of maintaining the levels at Western. It's declining. I don't know if it's significant or not, but there is some indication that it's declining. And 3x, it showed a sharp decline, but then it kind of is maintaining where it at a level. With respect to crop response, when no phosphorus fertilizer was applied across all those treatments, again, there is a lot of data out here. This is the corn data showing with respect to, again, different fertilizer rates. And then this is the soybean data. Just to summarize what's happening, at least at Northwest site, across the board, there are similar yields, whether it's 0, 1, or 3 times the phosphorus rate. At Western, there are some indications of positive yield response when the fertilizer was stopped. And then at Worcester, it's kind of mixed. With soybean, there is nothing happening, but with corn, at least, there is some indication of phosphorus response at this site in one of the years. So just to summarize, very preliminary data, as I mentioned, that soil P is declining with no phosphorus application since 2020-21. Critical level, if we are talking about, with 0 after all these years since 2006, now we are at a point that we are almost near or below the critical level. So essentially, that if we are talking about soil's perspective, that's not really a good approach to do. When we are talking about 1x, we are still within or above the critical soil test level. With 2 to 3 times where we were building up, we are way above the critical soil test level. And then when it comes down to crop response, there's kind of a mixed thing, positive, similar, and mixed response. So when I look over these findings, soil phosphorus is declining, but crop response is kind of not keeping up with what's happening with soil P. Something doesn't really add up. Something is missing in there. That's what kind of intrigues me to go down into further into these data sets to tease out all these details so we can have further refinement of our phosphorus fertilizer recommendations. One of the things that I kind of think very often is, let's go switch gears a little bit from all the data that I've been showing. Let's get to the basics of the phosphorus. When it comes to soil phosphorus, whatever I've been talking so far, when I said soil P, I was talking about soil phosphorus that we usually get in our soil test reports, the available phosphorus of the crops. However, in reality, that's not the only phosphorus that's in the soil. There are different forms and their availability to the plants differ. Very simplified figure over here. If we look over different forms, there is this available P form, which is available to the crops, readily available, and it's usually in the soil solution form. But at the same time, there are other forms which makes a huge proportion of phosphorus actually in the soil, organic P and inorganic P. And when it comes down to what is available and what is not available, when we do the soil P test, these tests are actually measuring what's in here, a little bit of what's in soil solution P and a bit of relatively available from like inorganic or organic P. Organic P and inorganic P in general are usually thought to be not available to the plants. Now, next thing that comes to my mind is when we talk about this available P phosphorus, crop is mining from this pool. And if we look over the tri-state recommendations, every bushel of corn, soybean, and wheat that we are producing is removing phosphorus from our system. That means that available pool should be replenished somehow. One way to do that is to add fertilizer that we have been talking for past half an hour, that add fertilizer to supply that phosphorus to the crops. But at the same time, what we are observing that it doesn't really respond to that added phosphorus fertilizer. At least so far, what we have understood, at least the majority of that response is based on soil P test level. But one thing that I wanted to mention over here is when we add phosphorus to the fertilizer, to the soil, it doesn't really end up all of it in here. What happens is it gets converted into non-available pools like organic P and inorganic P. For example, if you're adding a residue and the CP ratio is more than 300, then that phosphorus end up being organic P, not available to the crops. If you're adding inorganic fertilizers, that phosphorus, a huge proportion can also end up in inorganic pool, and that is usually based on what kind of soil pH you have. If you have low pH, it usually end up binding with iron and aluminum oxides or minerals. If you have higher pH, it's usually calcium and magnesium. So if we think about adding phosphorus fertilizer to our soils and expect a response out of it, it's not straightforward because we don't know what's happening with phosphorus fertilizer, whether it's here, whether it's going down to non-available pools or not. To summarize, so far, what kind of insight I am getting, at least from all these data sets, that when it comes down to phosphorus fertilizer applications, there's a strong indication that crop response can be expected or can be the probability can be at least configured based off soil p-test levels. And within that, you can refer to the 20 ppm level. That's what we were all discussing about. What I am interested when moving forward with this phosphorus research, I'm interested in why there was a response in only 34 to 67% of the trials. What happened at 33 to 66% of the trials when the P levels were less than 20 ppm? Why there was no yield response in those trials? What was the reason? Is it the inorganic or organic P forms? They are much more relevant when it comes down to crop nutrition than we usually think about. Is it the environmental conditions have a huge impact on how fertilizer application has an impact on the crop yield? Not just the weather condition, but also the soil conditions. Whether your soil is compacted or not, is it acidic or not, does it have good drainage or not? All those factors is how much significance that had when it comes down to determining the phosphorus response to crops. And then another point, when we talk about soil tests, we usually sample either upper 6 inches or 8 inches, but there are growers out here, there are CCS over here, researchers out there. Crops, well, majority of the crop root biomass in that 0 to 6 and 0 to 8, but that doesn't mean that crops roots doesn't go deeper than that. They do go there. But when we do the soil test, we don't usually measure that deeper depth phosphorus level. So what I'm interested in seeing is when we talk about that crop didn't responded when it was expected to be responded, was that crop actually those roots getting the phosphorus down from the 8 inches depth or not? So in other words, I want to quantify what's the significance of phosphorus, which is down below 8 inches, how much influence that have on crop nutrition. And another thing, when it comes to phosphorus, it's not just all the crop physiology or soil matrix, physical or chemical reaction happening. There are microbes there as well. And with phosphorus, the mycorrhizal fungi, that has a huge impact on interception of phosphorus and transferring it to the crop. So digging deeper down into microbial roles to intercept that phosphorus and what their role with respect to phosphorus supply, that's another angle that I would like to pursue. And then finally, very classic questions about why there was a response or not response. Was that related to how we applied the phosphorus? Was it broadcast? Was it banded? What was the timing of phosphorus application? Was it fall application? Was it spring applications? Those kind of questions, I think once we go deeper into this data set and start teasing out all these details, we will have much more confidence in explaining why there was a response, why there wasn't a response, why there was a yield increment, why there wasn't a yield increment. So these are some of the questions that I have in my mind moving forward when it comes down to phosphorus research. And if you have any questions in your mind with respect to phosphorus or any broader soil fertility questions that you have, you can submit that at this poll. I'm gonna activate it once I'm done with this talk, just for reference. But if you don't want to go to the poll, that's my email address, phone, to submit any kind of questions, or even if you want to discuss any kind of soil fertility questions you have, something that's very intriguing or interesting, or you just want to nerd about soils, how complex they are, I'm available there for phone call and email. I also use Twitter. That's my Twitter handle. If you want to stay updated with what's happening with soil fertility in Ohio State, that's a place to go. With respect to whatsoever I have shared in this presentation, if you want to read about it, there is an article on Corn Newsletter website recently published about 2 weeks ago. The fact sheet ANR 0146 at Ohio line goes a little deeper into this data set. That's another resource. And then finally, Tri-State Fertilizer Recommendation has a lot of good information when it comes down to phosphorus management. That's another resource for you to refer to. Again, thank you very much for your attention. I am looking forward to answer any questions, any follow-ups, and also very importantly, if you can just email or follow back with me or use this QR code for submitting your soil fertility related question, that will really help me to have my research, which is more of on-farm related or farmer oriented rather than me sitting in the office and keep thinking about weird questions. So that would be really helpful for me. With that, again, thank you very much. And I'm ready for the questions.